So first I'll import my model. In this case, I'm using a Parasolid file, which you can import from here, import Parasolid. If you don't see the option here on the top, you can go to this menu, file, import, then select this Parasolid option. Now go to Parasolid import, choose this file, 4-bar mechanism, double click on this, and I'll do the fit once, and let's see the geometry here. So in this geometry, I have four links, 1, 2, 3, and 4. And you can also see there are four holes which are cut through each other. This would be the location of my joints, which we'll see in the motion simulation environment. So let's quickly start the motion simulation environment, that is under application, motion. Now we are in this environment. Create a new solution and you can name it whatever you want to and press OK. So this would be a dynamic simulation, means we are considering the mass of the object. So this would be dynamic, and I'll untick this because while making this assembly I did not apply any constraint. That means I won't have any automatically created links or joints. So just untick this and then press OK, right? So now we'll start with the designing of the links. Before designing, I'll quickly name the parts that you are seeing on screen now. This is the fixed link. This bottom link is the fixed link. This left link would be my input, also called as a driver. This right one would be my follower, also known as the output. So this is the input or driver. This is the output or follower. This is my base link or fixed link, and this would be my coupler or connecting link. Now let's name this link number one. This is fixed link. Select this one, apply. Because I'm going to create the other links also, I want this command to be open. This left side link, this is my driver or crank. I'm naming this as driver. Middle mouse button. This right one is my follower or the output. Middle mouse button. And this is my coupler or connecting link. Okay. So on the left I have four links: fixed link, driver link, follower link, and the coupler. Now it's time to create the joints. So click on this joints, and we'll start with the revolute joint. So select revolute joint here, and this would be my link, and the origin would be the center of this circle. I'm making this direction outward from the plane. Base link is this one because this has this connection between them. Apply. And now for the second revolute joint, select this link, and the origin would be this. Vector is pointing outwards, and the base link would be this one. Apply. Now for the third link, this is the link. This would be my center, and vector is outside this plane pointing here. Base link is this one. Press OK. Select this link again, and origin would be now this center point. Vector is facing outward, and the base link is this one. Press OK. Now if you see here, I have four links and I have four joints. One main thing is left. I told you that this is the fixed link, but I didn't actually fix this. So right click on this, edit, makes this link as fixed one. Press OK. Also here, I would like to create a fixed joint. For that, go to joint, and make this as fixed. Select this link. Origin and vector actually doesn't matter, so you can give it anything. Just press OK. Now we are ready with the links and joints arrangement. The only thing that is left is the driver. Driver means the input we would be getting is from this link and the output would be this link. So this is my driver, right? So I need to apply the driver here, which would be in the form of rotation of polynomial based, and here I can give the velocity of, let's suppose, 30 degree per second. Press OK, and now this is my driver. How can I tell? Because if you see all these joints, this joint has a one unique thing, that this has a red icon on this, so that means this is my driver. And now we'll proceed to form a solution. For that, right click on this, new solution. This would be my normal run, and I guess 30 seconds with 500 steps is fine. That means in 500 steps this would be breakdown. Now press OK and wait for the results. Actually here the gravity's direction doesn't really matter, so just press OK and wait for a minute. It won't take much time because this is not a very complex geometry. So it's done 100%. Close this, go to this tab, analysis, and then animation. I'll adjust this here, drag this window here, click this option which is the loop option. That means when the loop of the animation has been completed, it will restart from the starting point. Now I'll just press this button and observe the result. Now if you see here, this was my driver. I am giving this input here in the form of a polynomial function of velocity 30 degrees per second, and I'm receiving the output here. So this was a simple tutorial made up of 4 links and a couple of joints, 4 evolute joints and 1 fixed joint. I hope you liked this tutorial. Moving on, we'll be going deeper and discuss more interesting examples. Thank you for watching.